Every night a massive ball of rock hangs above us, one we see so often that we've almost stopped noticing it. And yet without it, Earth would most likely have none of us, and none of the life we know. What's most astonishing is that our moon was born from a genuine catastrophe, a collision more violent than anything our planet has ever survived. Let's travel back roughly 4.5 billion years, to the very first 100 million years of the solar system's existence. A young Earth was just taking shape, still hot, still restless, and it wasn't alone in that space. Another planet, roughly the size of present-day Mars, was moving along a similar orbit nearby. Scientists gave it a beautiful name, Theia, after a figure from ancient Greek mythology, the mother of the goddess of the moon. And then these two worlds drew close and collided. The impact was of monstrous force. An enormous quantity of superheated material was hurled into Earth's orbit, and from that cloud of debris and vapor, in what feels like the blink of a cosmic eye, in just a few thousand years, the moon assembled itself. This bold idea of a giant impact was first proposed in the mid-1970s by two researchers, William Hartmann and Donald Davis. For many years it seemed nearly flawless, but one major mystery remained, one that scientists are still wrestling with today. When you examine the composition of Earth rocks and moon rocks side by side, they turn out to be almost indistinguishable, like siblings. But Theia arrived from a different part of the solar system and should have had a different composition. To explain this puzzle, researchers today are developing models of an ultra-powerful impact that mixed both bodies so thoroughly that they became virtually identical in composition. And quite recently, this story took an unexpected turn. Deep inside our planet, beneath Africa and beneath the Pacific Ocean, scientists long ago identified two giant regions where seismic waves travel suspiciously slowly. Their nature was once unclear, but one leading theory now links them directly to that same catastrophe. They may be dense remnants of Theia that sank into Earth's interior after the impact and have been sitting there ever since. It turns out that part of a dead planet may still be living inside us. Once the moon cooled, a new chapter in its history began, the birth of the face we know today. Those dark patches visible even to the naked eye are, in fact, frozen seas of lava. Long ago, enormous impacts struck the surface, carving out vast basins, and then liquid basaltic lava welled up from below and flooded them, forming the smooth, dark plains we see now. For a long time, it was thought these seas solidified somewhere between 3.9 and 3 billion years ago, but samples recently returned by Chinese missions forced a complete recalculation. Soil from the far side, brought back by the Chang'e 6 spacecraft, turned out to be younger than expected, around 2.8 billion years old, and Chang'e 5 samples showed that volcanoes were still breathing here roughly 2 billion years ago, far later than anyone had imagined. And this brings us to one of the moon's strangest features. It has two completely different sides. On the side facing us, dark seas cover nearly a third of the entire surface. On the far side, there are almost none, just craters and mountains as far as you can see. The explanation is that the crust on our side is noticeably thinner, and beneath it, a concentration of heat-producing elements has gathered. Elements scientists gave the shorthand name KREEP. That's precisely why lava broke through to the surface so readily on our side. And the moon's single greatest scar hides on its southern reaches. The South Pole Aitken Basin, roughly 2,500 kilometers across, one of the largest impact structures in the entire solar system. Now let's step back and look at the moon as a whole and appreciate its true scale. Among all the moons of the planets, it ranks only fifth by size, which sounds modest. But there's one record that makes it exceptional. Relative to its parent planet, the moon is the largest satellite in the entire solar system. Its diameter is about 3,470 kilometers, roughly a quarter of Earth's. Its surface area is about 38 million square kilometers, comparable to the entire African continent. In terms of mass, it's roughly 81 times lighter than our planet, meaning it amounts to just 1% of Earth's mass, and the Moon is far from a perfect sphere. It bulges slightly toward us, as if reaching for Earth, and its center of mass is shifted about 2 kilometers closer to us than its geometric center. That's partly why the far side ended up with a thicker, more heavily cratered crust. A mission consisting of 2 identical spacecraft, given the charming names Ebb and Flow, allowed scientists to peer inside the Moon. Flying one behind the other, they detected the faintest changes in their own speed to probe the Moon's entire interior. It turned out that the crust is thinner than previous estimates suggested, averaging about 40 kilometers, while the core is quite small, roughly 1/5 of the Moon's radius, solid on the inside and liquid on the outside. Gravity on the Moon is about 6 times weaker than on Earth, and this was once demonstrated in a wonderfully elegant way. Astronaut David Scott, during the Apollo 15 mission, held a heavy hammer in one hand and a light falcon feather in the other, and released them both at the same moment. On Earth, the feather would have drifted down slowly, but there, in perfect vacuum, the hammer and the feather touched the lunar surface together, exactly as science had predicted. The Moon has no global magnetic field today, only isolated magnetized patches in the crust, which paint strange bright swirling patterns across the surface. But in ancient times, things were very different. A powerful magnetic dynamo was running deep inside, and once again, Chinese samples delivered a surprise. It emerged that around 2.8 billion years ago, the Moon's magnetic field suddenly strengthened again, even though it had been fading for a long time before that. As for atmosphere in any familiar sense, there is none at all. The entire Moon is wrapped in only a ghostly thin shell of sparse gases, with a total mass of just a few tens of tons, less than a single truck and trailer weighs, stretched across an entire world. If the first part of this story was about rock and catastrophe, the second is about the most delicate and unexpected thing the Moon has to offer: water, and the remarkable dance it performs around us every single day, lifting the oceans and staging spectacular shows in the sky. Let's start with the fact that people mistook the Moon's dark patches for water long before science had anything to say about it. As far back as the 17th century, observers peering through the first telescopes decided that those smooth, dark plains were real seas and oceans. 2 Italian scientists, Giovanni Riccioli and Francesco Grimaldi, in 1651 gave these imaginary seas beautiful Latin names, many of which survive to this day. Among them, the Sea of Tranquility, the very one where, 3 centuries later, a human being would set foot for the first time. There wasn't a drop of actual water in any of these seas, of course, but the name stuck and became the poetry of the lunar map. Real water on the Moon, however, remained a dream for a long time, until the search began in earnest, and then the discoveries came one after another. In 2009, scientists took a bold step. They deliberately accelerated a spacecraft and drove it into a permanently shadowed crater near the South Pole, a place where sunlight never reaches. From the cloud of dust thrown up by the impact, instruments detected exactly what they were looking for: genuine water ice. Around the same time, a specialized instrument aboard India's Chandrayaan-1 spacecraft detected traces of water and a related compound across nearly the entire lunar surface, in a thin layer like invisible dew. But the most astonishing discovery came in 2020. An airborne observatory, essentially a large telescope mounted inside an aircraft, detected water molecules not in some region of eternal shadow, but on sunlit areas of the surface. That turned everything upside down. Water on the moon isn't confined to cold, dark places. It's far more widespread than anyone had thought. And those same Chinese samples mentioned earlier also contained chemically bound water. As for the ice reserves at the poles, estimates put them at hundreds of millions of tons. That's why polar water is the moon's greatest treasure today. Future colonists will be able to extract drinking water, breathable air, and even rocket fuel from it. Now let's talk about the moon's motion itself, because it holds one beautiful secret. The moon orbits us at an average distance of about 384,000 kilometers, and it always keeps the same face turned toward Earth. You've surely noticed that the face of the moon never changes. Why is that? It comes down to a phenomenon called tidal locking. The moon completes one rotation on its axis in exactly the same time it takes to orbit the Earth. It's like a dancer waltzing with a partner, always looking them in the eyes and never once turning its back. The full cycle of lunar phases, from new moon to new moon, takes 29.5 days, while the actual orbit around Earth is slightly shorter, about 27. The moon is what drives our ocean tides, and it does so with roughly twice the force of the distant sun. Its gravitational pull drags the ocean water along with it, raising it into a bulge. And when the moon and the sun line up in the sky, their forces combine, producing the strongest, highest tides. When they stand at right angles to each other, the tides are at their weakest. But this eternal tug-of-war has a remarkable flip side. By lifting Earth's water, the moon is gradually slowing our planet's rotation, and the day is slowly getting longer, by about a couple of thousandths of a second every century. That sounds trivial, but if you look back hundreds of millions of years, you find that the day was noticeably shorter back then, and dinosaurs lived through much faster days than we do. Now, let's talk about celestial spectacles. A lunar eclipse can only happen at a full moon, when the moon passes into Earth's shadow. Sometimes it's only partially dimmed, grazing the edge of the shadow, but sometimes it plunges in completely. And that's when the real magic happens. The moon doesn't disappear. Instead, it fills with a deep copper-red color. The reason is beautiful. Sunlight passing through Earth's atmosphere along its very edge gets refracted and sends red rays into the shadow. To put it poetically, in that moment, every sunrise and sunset happening right now, all around Earth's rim, is projected onto the moon at once. The ancient Babylonians, incidentally, noticed thousands of years ago that these eclipses repeat on a strict schedule in a cycle of about 18 years. The reverse sight, a solar eclipse as seen from the moon itself, was witnessed by people for the very first time only recently. In April 2026, the crew of the Artemis II mission, during their lunar flyby, watched our planet pass in front of the sun. The totality phase of that eclipse lasted nearly 54 minutes, an extraordinarily long time by Earth standards. The moon isn't always the same size in the sky, and that's no optical illusion. Its orbit is slightly elliptical, so at its closest point, about 356,000 kilometers away, the disk looks roughly 14% larger and about a third brighter than at its farthest point. A full moon at that closest point has been affectionately nicknamed a supermoon. The breathtaking giant moon you see near the horizon, on the other hand, is a genuine trick of our own perception. It's exactly the same size. Our brain simply compares it to trees and buildings and inflates it to seemingly enormous proportions. People have been debating this illusion, by the way, since the time of the ancient Greeks. And one more warm detail to close with. Although the moon keeps the same face turned toward us, it wobbles slightly, as if nodding, and thanks to these wobbles we eventually get to peak at nearly 60% of its surface, rather than exactly half. The moon is also slowly drifting away from us, by about 4 centimeters every year, and this has been measured precisely by bouncing laser beams off the reflectors that the cosmonauts left behind on its surface. Hundreds of millions of years from now, it will have moved so far away that it will no longer be able to fully cover the sun. And one day, billions of years from now, our sun will grow old and swallow both worlds. Earth and the moon, like two inseparable companions, will meet their final hour together. After the Great War, powerful rockets became available to humanity, and two great powers, the Soviet Union and the United States, launched a full-scale race to the moon. In the early stages, the Soviet program set the pace, bearing the simple and proud name Luna. In 1959, the Luna 3 spacecraft photographed the far side of the moon for the first time in history, the side no one on Earth had ever seen. Soviet scientists were the first to name its features, and that's how the Sea of Moscow and a crater named after Tsiolkovsky appeared on the map. 7 years later, Luna 9 made the first ever soft landing on the surface and sent back the first panoramic image of the lunar landscape in history, while Luna 10 became the first artificial satellite of another world and even broadcast the melody of the Internationale from orbit. Later, Luna 16 collected a sample of lunar soil entirely on its own, without any human involvement, and brought it back to Earth, while Luna 17 deployed Lunokhod 1, the world's first self-propelled rover to travel across another celestial body. But there's one particular mission in this story that deserves a closer look. In September 1968, the Zond 5 spacecraft became the first to fly around the moon and return home safely. And most remarkably, it carried living passengers. Two-step tortoises, several flies, plant seeds, and bacteria became the first Earth creatures to travel around the moon and survive, to witness it with their own eyes, so to speak. The spacecraft also transmitted recorded human voices for communication tests, including the voice of cosmonaut Pavel Popovich. When American operators intercepted these transmissions from space, they were genuinely alarmed, convinced that the Soviets were about to land a person on the moon. But it was others who were destined to set foot there first. In 1969, Neil Armstrong took his famous step across the dust of the Sea of Tranquility, and others followed. In total, under the American Apollo program through 1972, 12 astronauts visited the moon. They brought home about 380 kilograms of precious lunar rock and left instruments on the surface, laser reflectors and sensitive seismometers that went on listening to moonquakes for years afterward. Then came a long silence, lasting nearly half a century. Humanity seemed to turn away from the moon, caught up in its own earthly affairs. A genuine revival came only in the new century and from an unexpected direction. China's Chang'e program advanced step by step until, in 2019, the Chang'e 4 spacecraft became the first in human history to make a soft landing on the far side of the moon. It was an extraordinarily difficult feat, since Earth isn't visible from there, and communications had to be routed through a dedicated relay satellite in orbit. Then, in 2024, Chang'e 6 accomplished something truly unprecedented. It brought back samples from the far side for the first time ever, collecting nearly 2,000 grams of material and delivering them to Earth on the 25th of June. India also made a landmark breakthrough. After the painful failure of its previous mission, the Chandrayaan-3 spacecraft on the 23rd of August, 2023, became the first in history to make a soft landing near the moon's south pole. With that touchdown, India became only the fourth country in the world to successfully land a spacecraft on the moon, and the small rover named Pragyan confirmed the presence of sulfur and other significant substances in the southern soil. Private companies with no government ties also made their mark on the moon. In February 2024, a spacecraft proudly named Odysseus became the first commercial vehicle in history to soft land on the moon, though it tipped onto its side during touchdown. Then in March 2025, a spacecraft with the poetic name Blue Ghost landed upright and performed flawlessly. Russia, meanwhile, revived a proud old name. Luna, 25, set off for the South Pole in 2023, but sadly it crashed just a few days before India's triumph. And a Japanese spacecraft landed with record-breaking precision, yet somehow managed to tip upside down as well. The defining event of this decade, though, is humanity's return to the moon. After an uncrewed test flight of the spacecraft in April 2026, the Artemis II crew, Reed Wiseman, Victor Glover, Christina Koch, and Canadian Jeremy Hansen, flew around the moon and broke the record for the farthest a human being has ever traveled, a record that had stood since Apollo 13. A crewed landing near the South Pole itself is planned for around 2028, and as the 30s approach, China and its partners are dreaming of building a permanent crewed station there. The moon has long been a place of remembrance too. To this day, the only person whose ashes truly rest on the moon is geologist Eugene Shoemaker, who devoted his entire life to studying it. A small portion of his remains was carried there in 1999 by a dedicated spacecraft. A touching attempt to send the ashes of the creator of the famous Star Trek to the moon, however, fell short. The lunar lander never reached its destination due to a fuel leak and burned up in Earth's atmosphere. But what moves me most is what people have left on the lunar surface simply out of the goodness of their hearts. In 1971, the Apollo 15 crew placed a small aluminum figurine called the Fallen Astronaut on the surface, along with a plaque commemorating all those who had died in the conquest of space, theirs and ours alike, with no distinction. Nearby rests a silicon disc carrying goodwill messages from the leaders of dozens of nations. Astronaut Alan Shepard even managed to play golf up there, and his golf balls are still lying in the dust to this day. And Charlie Duke left a family photograph of his wife and sons on the moon, so that a piece of his home would remain among the stars forever. Remarkably, people were unraveling the moon's secrets long before rockets existed. The Babylonians calculated eclipse cycles from clay tablets. The ancient Greek Aristarchus was already trying to measure the distance to the moon using geometry alone as far back as 300 BCE. And the crowning achievement of ancient thought was the Antikythera mechanism, a genuine geared computer of its era, capable of predicting eclipses. And so the moon remains our key to the entire history of the solar system, from the catastrophic impact of Theia to the people flying back toward its gray shores today. Its past and its future are still bound to ours, inseparably. Subscribe, and we'll see you in the next episode.